Shilpa Kantekure, working as Assistant Professor in Department of Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. The topic for today's video lecture is Understanding Hill Cipher. Learning outcomes. At the end of this session, student will be able to understand basics of Hill Cipher in network security, and students will be able to encrypt a message using Hill Cipher technique. These are the contents. First, we will learn the basics of Hill Cipher technique, and then we will understand the process of encryption using Hill Cipher technique with an example. The famous American mathematician Leicester Hill developed and improved the Hill Cipher technique in 1929. In the context of classical cryptography, the Hill cipher is a polygraphic substitution cipher, meaning it encrypts multiple letters at once. Hill cipher is a block cipher which can function with any block size like digraph means 2-letter block, trigraphs means 3-letter blocks, and any other multiple sized blocks to create a uniform cipher. Hill cipher is based on linear algebra, matrix multiplication, matrix inverse, and modulo arithmetic principles. It is more mathematical cipher than others. Hill cipher uses key is a square matrix of numbers which is typically 2 by 2 or 3 by 3 matrix. Hill cipher becomes more complicated as the key matrix size grows. Hill cipher is used to overcome the frequency analysis attacks that easily break simple substitution ciphers. To understand the Hill cipher, students must know the alphabet to number mapping. So each letter of the alphabet is assigned a number from 0 to 25, like A is assigned with value 0, B is assigned with value 1, like that Z is assigned with the value 25. Students also should know matrix multiplication, that is the process of multiplying a matrix by a vector. Modulo 26 arithmetic is also needed to understand Hill cipher, which is performing mathematical operations and then taking the remainder when divided by 26. So let's understand what is the Hill cipher encryption formula. So the encryption process, it can be summarized by the matrix equation, which is C equal to P into K of mod 26. Now here C is the resulting ciphertext vector, which is a column and a row matrix. P stands for the plaintext vector, which is again a column and a row matrix, and K stands for the key matrix. Now let's encrypt a plaintext message help using a 2 by 2 key matrix, which is shown in the screen. Now first we have to prepare the plain text. So for that we have to convert the plain text to the numbers. So we have to map the letters of help to their numerical equivalents. So H is mapped to number 7, E is mapped to 4, L is mapped to number 11, and P is mapped to number 15. Now we have to divide the plain text into blocks. So as the word is help, so we will divide it into 2 diagrams. So first is HE and the second is LP. So HE means H maps to 7 and E maps to 4, and L maps to 11 and P maps to 15. Now next step is to perform matrix multiplication. Now here is our key which is provided to us, and 7 and 4, this is a matrix which represents H and E. So when we do matrix multiplication, we have to do as per the arrows shown in this. So 3 into 7 plus 5 into 4, and then 4 into 7 plus 7 into 4. So after this matrix multiplication, what we get is 41 and 56 are the values. Now we have to perform the modulo 26 operation on the obtained values. So first, to perform the modulo 26 operation, first we have to divide that number by 26. So we have to take the result of the calculation from the matrix multiplication, divide it by 26. Then we have to use the remainder. So whatever the remainder of the division is, it is the final result of the modulo 26 operation. So example how to do this. So if 41 mod 26 is what we have to do, we have to perform the mod 26 operation on the number 41. So first we will divide 41 with 26. Okay, the quotient is 1 with the remainder of 15. So that means the result is 15, which corresponds to the letter P. Now if 56 mod 26 is what we have to do, that means we have to perform mod 26 operation on the number 56. Then we have to divide 56 by 26. 2 is the quotient and remainder is 4. So 4 is our result because we take the remainder into consideration. Now 4 corresponds to the letter E in number mapping. Now let's apply modulo 26 to our example, which is H and E. So 41 and 56 are the values which we obtained, and we have just seen how to perform the modulo operation on 41 and 56, and this is what we got the respective answers. So 15 maps to P and E 4 maps to E. So that's why our cipher text is P and E. Now let's perform the matrix multiplication for the second diagram of our example, which is LP. So this is our key matrix and this is the matrix which corresponds to our diagram L and P. So we will multiply this. So 3 multiplied by 11 plus 5 multiplied by 15, and then 4 multiplied by 11 plus 7 multiplied by 15. So after all calculation, we will get the numbers 108 and 149. Now we have to apply similarly the modulo 26 operation on the values 108 and 149. So the answer we got is 4 for 108 mod of 26, which corresponds to the letter E, and 19 is the answer for mod 26 operation on 149, which corresponds to letter T. So the second cipher text block is E and T. Now we have to combine both the encrypted blocks to get the final cipher text. So for HE, the first diagram. So the Hill cipher offers more security than conventional substitution ciphers, as it works with blocks of letters rather than single letters. The size of the key matrix is unpredictable, and the large key matrix will make it more challenging for unauthorized parties to decrypt the message. So these are the advantages of Hill cipher. Now drawbacks. So Hill cipher is vulnerable when it comes to defending against known plaintext attacks. The matrices are easily broken because it uses only conventional algebraic procedures for solution. And the third, it can be quite ineffective when it comes to modern encryption systems that offer 256 possible number possibilities. These are the references used. Thank you.